This is for Year 11 methods. They're both questions about quadratics. In question 5, find the quadratic function such that f of 2 is the same as f of 4, which equals 0, and 7 is the greatest value. Okay, so I know that for my quadratic, f of 2 is 0, f of 4 is 0. And I know its highest value is 7. So since that's an x-intercept, then the turning point will be dead middle, and this is what my parabola looks like. And I know that that will be 3 and 7 because that will be dead middle between the two x-intercepts. So if I use the rule y equals a x minus 3 squared plus 7, because my turning point is 3 and 7, I can then use this point. 0 equals a 2 minus 3 squared plus 7. 7 equals a. Therefore, y equals 7. X minus 3 squared plus 7. And that's going to be the general equation for my parabola. Because I knew the greatest point was 7, therefore the y-coordinate of my turning point was at 7 because it was the greatest value, therefore it's the turning point, local maximum. And I knew that it was 3 because I was given my two x-intercepts. Okay, in question number 9, find the value of k so that this is greater than 1 for all values of x. So, if I set 3x squared minus 5x minus k equal to 1, then I move the 1 over, 3x squared minus 5x minus k minus 1 equal to 0, I now want this always bigger than 0. And if this is always bigger than 0, therefore there's no solution, therefore the discriminant must be negative. So, b squared minus 4ac has to be bigger than 0. b squared will be minus 5 squared minus 4 times 3 times c, and c is minus k minus 1, has to be bigger than 0, has to be less than 0. 25 minus 12, or plus 12 times k plus 1. I've taken a negative 1 out of there and a negative 1 out of there and turned them into positive. Has to be less than 0. 25 plus 12k plus 12 is less than 0. 12k is less than 37. K has to be less than 37 on 12. And when k is less than 37 on 12, and just double checking my work here, that has to be a negative and that has to be a negative. So k is going to be less than negative 37 on 12. Okay, show that for k the minimum value occurs when x is equal to that. Okay, so for f of x equals 3x squared minus 5x minus k, the minimum value of this parabola, that is a positive parabola, will be at the turning point. And the x value of the turning point is dead middle between the two x-intercepts, or if I've got it in turning point form, but I can't put it in turning point form because of the k there, is going to be minus b over 2a, which in this case is minus 5 over 2 times 3 is 6, which is 5 on 6. And that's what I had to show you. Find the k if the minimum value is 0. So if the minimum value is 0, if I'm substituting in mind 5 on 6, then when x equals 5 on 6, y has to equal 0. So 0 equals 3 5 on 6 squared minus 5 times 5 on 6 minus k. 0 equals 3 times 25 on 36 minus 25 on 6 minus k. 3 goes into that 12 times. So 0 equals 25 on 12 minus 50 on 12 minus k. So move the k over. K equals 25 on 12 minus 50 on 12 is minus 25 on 12. Done.